So we're going to use the set builder notation to express the squares of integers that are found between 1 and 110. Well, the simplest way to do this is to take the square root of 110 to kind of give an idea what it's going to be. And our maximum then, the square root of 110 is about 10.5. So that means we're going to take all the integers that have a perfect square that's less than 11. So it'll be 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. And we're not going to include 1, so we're not including it. So the letter you start off with, we always start off with a bracket here. I can't really write it that well. And this one we can say, x or n or whatever, doesn't really matter. I believe they're going to use n for this. So this is the n squared where, or such that. N is an integer, so we say n is an integer. There's like a double z they're going to do here. I can't write that out really that cool like they do. And we also need to add the restriction that the n is going to be somewhere between 1 and 11. So, and then we close this off with another bracket. And note, we could say something like 1 is less than n, less than or equal to 10. There's different ways we could represent this. Or we could say, change that 1 to a 2 here, and then put a, make that a less than or equal to. So there's different ways we could finish that part off. Next one is we're going to describe all the real numbers that are greater than 5 and less than or equal to 11. So in this one, we're still going to start off with our bracket. And this time, let's use the letter y for our variable. It's part of the real numbers, and when we have the real numbers, we're going to represent with that with a r, or really a double r, which I'm not that good at writing out, such that our y is going to be in the middle of 5 and less than or equal to 11 there. And then it goes off the bracket, and I can't really write that too well either. And the last one is writing the set of write the set builder notation that denotes the set of positive odd integers greater than 11. So let's use, to understand real quick, we're going to have a restriction to where, we're going to use p here. I'm going to do something with p, and p is going to be a part of the integers because it's going to be much, much easier to represent with an integer than anything else. And sometimes they might even use like a little plus sign here if we just want all the positive values. If we have an integer, and we notice that if an integer is always divisible by 2 if it's even. And if it's not, what can we do to 2 times a number to make it odd? Well, we can add 1 or we could subtract 1. So the setup could be a little bit up to you if it was like an essay. But I believe they typically do a 2p plus 1. So 2p plus 1, where p is part of z, p is an integer, and we need to think about the part that's greater than 11. So all the odd numbers are greater than 11 start with 13. So it'd be 13, 15, 17, dot, dot, dot. So what p would we put in here to make this equal to 13? Well, again, there's 2 ways we could do this. We know that the first one would be 6, since 2 times 6 plus 1 is 13. So we could say that p is greater than 5 to close this out. Or we could say that p is greater than or equal to 6. Either one of those would be perfectly acceptable and fine. If you have any questions, go ahead and email me.